So 3.6 is going to be derivatives of log functions. We're basically going to learn how to find the derivative of log base a of x and natural log of x. Okay, so here are the two rules if I just look at them. The derivative of log base a of x is 1 over x. Now again, whatever this is going to be in that spot times natural log of your base. Always. So that is my rule. And then again, if x is not just x, then I would have to multiply it by the derivative of whatever is in that spot. Okay, and the derivative of natural log of x is just 1 over x. But again, whatever is here, I'm going to put here. And then if this was not just x, I'd have to multiply by the derivative of whatever was there. Okay, and same thing, natural log of absolute value is the same. 1 over x times, so down here I have times the derivative of x in each case. It also can be written as if I'm taking the derivative of natural log of some function, it's going to turn into the derivative of the function over the function. Okay, because that's the same thing as 1 over g of x times the derivative of g of x. So I could just write it as this over this. I'll show you what I mean when I go through and do some examples now. Okay, so the first example, differentiate, it is a natural log. So I start and I'm just going to have 1 over x cubed plus 1. So it's just 1 over whatever's here times the derivative of this, which is 3x squared. So I could just write that answer as 3x squared over x cubed plus 1. So that's where the definition I just went over. You have the g prime of x, which is this, over itself, g of x. Okay. Second one, very similar, natural log of sine. So I'd have 1 over sine times the derivative of sine, which is cosine. So doing a little simplifying, this turns into cosine over sine, which is what? Cosine over sine would be cotangent. So I could write my answer as cotangent. Okay. Next one, so these are pretty simple, but just giving you a basic idea of how this works. Next one now, I have the square root 3.6 is going to be derivatives of log functions. So now my outside function would be the square root. Learn how to find the derivative of log base natural log of x to the 1/2 power. Okay, so here are the first thing I need to do is bring down the 1/2. The derivative of log base a of x is negative 1/2, so normal x. Now again, whatever, and then I would multiply by the derivative in that inside times natural log is just 1 over x. Always. Okay, so if I want to clean this up a little bit, and then again, 1 if x is not just x, in the denominator, have to multiply it by the derivative of whatever is in that spot. And natural log to the 1/2, natural log of x is just 1 over x. But again, okay, so whatever is here, I'm going to put here. Natural log of x. And then if this was not just x, I'd have to multiply by the derivative of whatever was there. Simplification of this will be, and same thing, natural log of absolute value is the same. 1 over x times. So down here I have log, finally a log of x. Log base 2 of x. It also can be written as if I'm taking the derivative of natural log of some function. Okay, so it's going to turn into the derivative of the function over my log rule. Okay, so my log the same thing as 1 over g of x times this stuff, the derivative. Okay, so 1 over x, I could just write it as this really x squared plus I'll show you the x times in the denominator the natural log of the base. So natural log of 2. Okay, so the first example, differentiate, it is a natural log. Now, so I start and I'm just going to have the derivative of this, which would be 2x plus e to the x. Whoops. Plus, so it's just 1 over whatever's here times the derivative. So I could write my answer as 2x plus e to the x. So I could just write that answer as 3x squared plus e to the x times plus 1. Natural log of 2. So that's where the definition I just went over. You have the derivative prime of x, I can't factor anything out, over itself, g of x. Okay. Second one, very similar, natural log of sine. So I'd have 1 over sine. Number 5, I have the natural log of x plus 1 is cosine, the square root of x minus 2. So doing a little simplifying, this outside would be natural log. So the first thing I would do is 1 over all of this, because it's always 1 over whatever would be I'm taking the natural log of. So I could write my answer as cotangent. now times the derivative of this, which now I would have to use. These are pretty simple, but just giving you a basic idea of how this works. So derivative
Next
of
one
numerator
now,
is
I
1
have the square
times
root
denominator
of
natural log of x
minus.
So now my outside
numerator,
function would be the
which
square root.
is x
So
plus
if I
1
wanted to, I could rewrite
times
this
derivative
as
of
natural log of
denominator,
x
which
to
would be
the
1
1/2 power.
x minus
So the
2
first thing
to
I
the
need to do
negative
is bring down the 1/2. And then times derivative of
make it
inside,
negative
which is
1/2,
just
so
1,
normal,
all
okay?
over,
and then I would
denominator
multiply
squared,
by
which
the
would just
derivative
come
of
out
the
to the
inside
derivative of natural log
square
is
the
just
square root.
1 over x. Okay.
So that
Okay,
looks
so if I
messy.
wanna
I can
clean
do
this
some
up a
work
little
to this.
bit.
I can
I'd
flip
have 1 over the 2 would be
this
in the
fraction,
denominator.
so it's really
The
just
x would be in the
square root of x
denominator
minus 2
and
over
natural log to
and
the
then
1/2.
if I look
so I'm
up
gonna write it
here,
as root
this is
natural log
really
of
x minus 2 to the 1/2.
Okay, so 1 over
So I have
2x
x minus 2 to
root
the
natural
1/2,
log of
and I have
x.
x minus 2 to the negative 1/2.
So I'm going to
Next
factor
one, I'm gonna
out
clear
x
some
minus
space.
2 to the
My
negative 1/2.
simplification of this will be
Smaller
a little bit
exponent.
longer.
Okay,
So
and
number
I would
4,
be left with x
I
minus
have
2.
log, finally a log
take
1.
x
Log
minus
base
2 to the
2
negative
of
1/2
x
out of 1/2.
I'd be left with
Squared
to the first power plus
okay,
e to the x
minus
okay, so
1/2.
I'm going to first
and
just
then
apply my log rule. So my log rule is 1
I have the x
over
plus 1.
this stuff. Okay,
And
so
then
1
all
over
over
x,
x
which would be
minus
really
2.
x squared plus
Okay.
e to the x.
I'm going to
Simplify
times
inside my
in the
denominator
brackets
the natural log
and
of
x minus
the
2 to the
base.
negative
So
1/2
natural log of
times
2.
x minus 2 to the 1/2.
Okay, so that's the only
would just go away.
difference
It would
between
just
natural
be,
log and log. X minus 2
now,
to the 0.
chain rule would say
So these
times
two
the derivative
cancel
of
nicely.
this, which would be 2x
Inside the
plus e to
bracket,
x.
simplify
Whoops.
if I
Plus
distribute the negative
e to
1/2.
the x.
Simplify to
So I could write my
1/2
answer
x
as
minus
2x
5/2
plus e to the x over,
and then I would have over
x squared
x plus 1
e to the x
minus 2
times
natural log
if you
of
follow
2.
that.
Kind of messy, but
And the last thing I can
that's
do,
all
so I don't
do.
have a
can't
complex
simplify anything,
fraction,
I can't
is really
factor
take a
anything out.
1/2 out of the
Okay.
numerator, and it would turn into just x minus 5 over 2
So
times x plus 1, x
couple
minus
more.
2.
all I
Number
did was take a
5,
1/2
I
out
have
of this,
natural
guys,
log of x plus 1
and I'm left
over
with
the
x
square
minus
root of
5
x minus 2.
and then write the 1/2.
So
put the
outside
2
would be
down here.
natural log, so the first thing I would do
So I don't
is
have a
1
complex
over
fraction.
all of
Okay.
this, because it's always 1
All right,
over whatever
couple more.
I'm taking the natural log of.
So I have, next example I
Now
have
times the
oops.
derivative of this, which now I would have to
Um,
use the
number I'm
quotient rule to
saying
do the derivative of that.
redo this problem.
So derivative of
rewriting
numerator
it
1
first using
times
your
denominator
laws of logs.
Okay, so
Minus
before I differentiate,
which
I
is
just
x
did,
plus
if I
1
wanted to, I
times
could remember
derivative
from
of
last
denominator,
year,
which would be
change
1/2
this to
x
the
minus 2
natural
to the
log
negative
of
1/2
x plus 1,
and then times
minus
derivative
the
inside,
natural
which
log
is just
of
1,
the square root
all
of x minus
over
2.
denominator
Using
squared,
my
which would
rules,
just come out to be x
and I
minus
could go to
2.
step further,
square
and
the
I
square
could
root.
write this
Okay.
as
So that looks
1/2
messy. I can do some
natural
work to
log
this. I
of
can
x
flip.
minus 2.
So that's just using
This
my logs
fraction,
to
so it's
change
really
the
just
problem.
x, the root square root
Now
of x minus 2
differentiate.
over.
Okay, so
And
all I
then
did
if
was
I look up
simplify.
here,
Now find the
this
derivative
is
of this.
really
So the derivative
x
of this
minus
term
2
is
to the
1
1/2
over x plus 1.
So I have
times
x minus 2 to the
don't need
1/2,
that, and I have x minus 2 to the
minus
negative 1/2. So I'm going to
1/2
factor out
times
x minus
1
2 to the
over x
negative
minus
1/2.
2. Smaller exponent.
And then if I
Okay,
simplify
and
this,
I would be
1
left
over
with
x plus
x
1
minus 2.
minus not
If I
much I
take
could
x
do.
minus 2 to the negative
So you
1/2
might
out
say,
of
wait, it
1/2
doesn't
would
look
be
the
left
same.
with
If you found
the
a common
first power.
denominator here, it would be the exact same answer.
Minus
one more step with a
1/2,
common denominator, I'd have,
and then
if you did it, I'd have x minus 5 over
I have
2
the x plus 1
times x plus 1 times x minus 2.
and then all
Common
over
denominator
x
from here to here.
minus
Common denominator
2.
would obviously be all three of
Okay.
these. I'm going to
then I'd
simplify
have 2x
inside my
minus
brackets
4
minus x minus 1
and
which
x
gives me
minus
the
2
x
to the
minus
negative
5.
1/2 times
Okay,
x
so
minus 2 to the
If
1/2
you
would
can
just
approach
go
the
away.
problem
It would
either
just
way. I
be,
can use my
x
law
minus
of
2 to the
logs to
0.
rewrite the original
these
problem
two
first.
cancel
I think this
nicely.
is easier. Inside the
you don't-
bracket,
you just have to
simplify if I
recognize that
distribute
you
the
can do
negative
that.
1/2.
And then
Simplify
the last
to
part to
1/2
this
x minus 5/2 is, and then I would have over
what's called
x plus
logarithmic
1
differentiation.
x minus 2.
Okay,
So I have the steps here. It might not
if
make
you
sense
follow
till I
that.
do a problem.
Then the last thing
Um,
I can do
I
so I don't
have
have a
to
complex
use
fraction
this
is
in
really
certain
take a
cases
1/2 out of
where
the numerator.
x is my base
and
and
it
my
would turn
exponent. So
into
for example,
just
if
x
I had,
minus 5
if I wanted to
over
differentiate
2
x to the x
times
I don't know how
x
to do
plus
that right
1,
now.
x
There's no
minus 2.
rule. I can't
All I
bring
did
an
was take
x
a 1/2
down.
out of this,
Obviously,
guys,
x to a
and I'm
number,
left with
I
x
can
minus
bring
5,
the 2 down and then
but
write the
this
1/2.
put
We
the
don't
2
have
down
any
here.
rules for that, so I'd have
so I don't
use
have
what's
what's called
complex
logarithmic
fraction.
differentiation.
Okay.
Here are the steps.
All right.
So you're going to take
Couple more.
natural log of both sides.
So
And then you're
I
going to use your
have next
laws to
example I
simplify.
have
Then you're going to differentiate implicitly what we just did.
Number,
and then you're
I'm
going to
saying
solve for y
redo
prime. This problem, you can kind of go back
rewriting
to
it
those
first
as you're
using
doing,
your
as we're
laws
doing a
of
problem.
logs.
It might make more
Okay,
sense.
so before I
just have a couple
differentiate,
examples to go through.
I just did.
Okay. If I wanted to,
So
I
differentiate
could remember
this
from last
using
year, change
my
this to
logarithmic differentiation.
the
I wouldn't
natural
have to.
log
I could
of
just
x
use
plus
the
1
quotient rule, but I'm going to show
minus
you how I
the
could use
natural
logs
log
to do
of
it.
the square root
So I
of
would
x
first
minus
step
2
is turn
using
this
my rules
into,
and then I could go to step further and I could write this.
so there's no natural log
as
right now,
1/2
obviously. So I would
natural log
take the
of
natural
x
log
minus
of
2.
both sides.
So that's just
so
using
that
my
I
logs
could
to
apply
change the problem.
Now
Laws of
differentiate
logs to the problem.
Okay, so all I did
So
was
that's
simplify.
my first step.
Now find the
Oops.
derivative of this. So the
Over
derivative of this term is 1 over x plus 1 times
take
1.
natural
Don't
log
need
of both
that.
sides. That's all I did.
Minus.
Okay. Now I'm going to use my
1/2
properties to the right
times
side
1 over x minus 2
to rewrite it. So now I could rewrite this
and then
as
if I simplify
3/4
this, 1 over x
natural
plus
log
1
of x
minus not much
plus
I could do.
1/2.
So you might say, wait, it doesn't
natural
look
log
the
of x
same.
squared
If you
plus
found
1.
a common
Just using
denominator
properties
here,
from last
it
year,
would be the
I
exact
bring the
same
power
answer.
in front.
Okay, so
multiplication,
one more step
addition,
with a common denominator,
and then
I'd
minus
have,
5
if you
times
did it,
natural
I'd have
log
x minus
of
5
3x
over
plus
2 times
That's
x
just
plus
using
1
properties.
times x minus 2.
Okay.
Common
Now I
denominator
could
from here to
differentiate
here.
both
Common
sides. So the
denominator would obviously
derivative
be all
now
three
of
of these,
natural log of y
and then I'd have 2x
would be
minus
1
4
over
minus
y,
x minus
same
1,
rule,
which gives me the
and
x
then
minus 5.
times derivative
Okay,
of
so
this, which would be
if
y
you
prime.
can
Here's
approach the
implicit
problem either
part.
way. I can use my
Okay.
law of logs to rewrite the
Equals
original
natural
problem
log
first. I think this is
of
easier.
x is just 1 over
You
x,
don't-
so I would
you
just have the
to
constant
recognize that you
times
can do
that. Plus,
And then
I
the
have
last
1/2
part to
this times 1
is
over x squared plus 1
what's
times
called
derivative of
logarithmic
x squared plus 1,
differentiation.
which
Okay,
is
so I have
2x.
the steps here. It might not make sense till I do a
minus
problem.
5
I
times
have
1
to
over
use this in certain
3x plus
cases
2
where
times
x
derivative
is
of
my
that, which
base
is
and my
3.
exponent. So for example, if I
So
had,
again, this is
I
probably
wanted to
easier than doing
differentiate x to
quotient
the
rule
x,
and
I
product
don't know how
rule
to do that
start
right now.
in that
There's
original
no rule.
problem.
I
Okay?
can't bring an
Now I'm
x
just going to
down.
clean this
So
up a
obviously
little bit.
x to a
So I would have
number,
3
I
over
can bring
4x
the 2
would
down.
be my first
But
term.
this,
Okay.
we don't have any rules
plus
for that,
this
so I'd
would
have
turn
to
into the
use what's
2's
called
would cancel,
logarithmic
so I would just have x
differentiation.
over x squared
Here are the
plus 1.
steps. So you're going to take natural
And
log
then
of both sides.
Minus,
Then you're going to
I
use your
have
laws to
15
simplify.
over 3x
Then
plus
you're going
2.
to differentiate
Now
implicitly
the only
what we
thing
just
you have
did.
to remember
And then you're going to
in
solve
these
for y
problems
prime.
is I want y prime.
You can
And
kind of
right
go
now I
back
have
to those
1
as
over
you're
y
doing, as
times
we're doing
y
a
prime,
problem.
so I'd have to
It might make
multiply
more
both
sense.
sides by y.
I just have a couple
to get my
examples
final
to go
answer.
through.
I
Okay.
have to take this entire
So
thing
differentiate
times
this
y.
using
my
so my final answer I'm
logarithmic
going to write down
differentiation.
here.
I
y
wouldn't
prime
have
would be
to. I could
this
just use
whole
the
thing
quotient rule
but I'm going to
times
show you how
my
I could
original
use logs
equation,
to
which
do
was
it.
y here.
So I would first
So I'd
step
have
is
3
turn
over
this
4x
into
plus
x
x
over x squared plus 1.
So there's no
minus
natural log right
15
now,
over
obviously.
3x plus 2
So I would take the natural
times
log of both
y,
sides,
which
so
I
that
wanna
I could
rewrite in
apply
terms of
the
x as
laws
x to
of
the
logs to the
3/4
problem.
So
times
that's my
the square
first
root
step.
of x
Oops.
squared plus 1
over
3x plus 2 to the
3x
fifth.
plus
So just
2
take
to the
natural
fifth.
log
That
of
would be
both
my
sides. That's all I
nice,
did.
neat answer right there.
Okay.
Hmm.
Now I'm going to use my
Okay.
properties to the right side
And
to
then
rewrite
last
it.
one.
So now I could
I
rewrite
have
this
a
as
very common problem is
3/4
we're going to see often.
natural
I
log
have
of
two more.
x.
You have to use log. Okay, so
plus
these you
1/2
have to use logarithmic
natural log of
differentiation
x squared plus
because
1.
how are
I'm
you
just
going to
using
know?
properties from
If I
last
look
year.
at this,
I
have
bring
an
the
x
power
as
in
my
front,
base and in
multiplications
my
addition.
power. Down
And
here
then
I have
minus
an x base
5
and in my power
times natural
Okay,
log
so I would have
of
to
3x
go
plus
ahead,
2.
take natural log of
That's
both
just
sides.
using properties.
Okay. Now I
The
can
reason
differentiate
y
both
is
sides.
a
So the
natural log
derivative
allows me
now
to
of
take
natural
this
log
and
of
put it in
y
front
to get it out of
would
the
be
power.
1 over y.
So now I have
Same
natural log
rule.
of y
And then
equals the square root of
times
x
derivative
times
of
natural
this,
log of
which
x,
would be y prime. Here's
now
the
I can
implicit part.
differentiate both sides.
Okay.
So this would be 1 over
Equals
y prime.
natural log
It'll all be like that.
of x is just 1
Over
over
here,
x,
I'm going to
so I would
remember to
just
have
use
the
product rule
constant
with
times
these
that.
two.
Okay.
Plus,
When I go
I
to
have
differentiate
1/2
this, I'd have
times,
to use product rule
1
with
over
root
x
x and
squared
natural
plus
log of
1
x
times
So
derivative of x
of
squared
root
plus
x,
1,
I
which
have
is
2x,
2x,
x to the negative 1/2
minus
times
5
natural log of
times
x
1
plus
over
3x
3x
plus 2
times 1 over
times
x.
derivative of that, which is 3. Okay, make this look a little
So
neater.
again, this is probably
I have 1/2
easier than doing quotient rule and product rule to start in that original problem. Okay.
Change this.
Now I'm just going to clean this up a little bit.
Over 2 root
so
x.
I would have 3 over 4x
Plus
would be
root
my
x
first
over
term.
x.
Okay.
That's just simplifying each term,
Plus,
guys.
this would turn
X
into
to the
the
negative
2's
1
would
half,
cancel,
so
so I would just have x
over x
and then
plus
again,
1.
I'd have to multiply both sides by
And
y.
then
So y prime would be the
minus
my answer
15 over 3x plus 2
plus root x over
now
x.
the only thing you have to
times
remember
the original problem,
in these
which was
problems
x
is I
root
want
x.
y prime
in order to get
and
the
right
y
now I
prime
have
by
1
itself.
over y times
Okay.
y prime, so I'd have to multiply both sides by y.
And
To get my final answer, I'd have to take this entire
last
thing
one, similar
times
okay,
y.
So I have 2x
So my final
times,
answer I'm going to write down
2
here, y
times
prime
x
would
to the
be
sine x.
this whole thing.
So I'm going
times
to
my
can
original
write
equation,
this-
which was y here.
Really,
So I'd
it's
have
just y
3
over
equals,
4x.
don't let that confuse you.
Plus
Take
x
natural
over
log
x
of
squared
both
plus
sides, minus 15 over 3x plus 2 times
Okay.
y, which
Um,
I want to rewrite in
now I
terms
can
of
actually
x
split this the right
as
side up.
x to the 3/4.
So that's really the natural log
times
of 2
the square root of x
plus
squared plus 1,
the natural log of x
over
sine x to the sine
3x
x.
plus 2 to the 5th. That would be
Okay.
my nice, neat answer
and
right there.
then I'm still, all I'm
Okay.
doing, I haven't differentiated yet.
All
I'm
right.
just using my
And then
log
last one,
rules. Bring down the
I
sine
have
x. A very common
times
problem
natural log of
we're going
x.
to see
Now I'm ready to
often. I
differentiate.
have 2 more.
So
You have to
this would
use
be
log.
1
Okay,
over
so
y,
these
y
you
prime.
have to use
Derivative
logarithmic
of
differentiation
would be
because
0.
how are you
It's a
going to
constant.
know? If I look at
Okay.
this, I have an
So
x
then I
as
would
my
have to use
base
product
and
rule
in
with
my
sine
power.
x natural log of
Down
x.
here I have
So
an x
derivative of
base
sines,
and in my
cosine.
power. Okay, so
Times
I would
natural log
have
of
to
x
go ahead
plus
take natural log of both
sine
sides.
times 1 over x. The reason
And
why
then
is
would
a
just
natural log allows me
multiply
to
by y
take
to
this
get
and
the
put
y
it in
prime
front to get
so
it
my
out of
final
the
answer
power.
So
would
now I have
be
natural log of
cosine
y
of x
equals
times
the square root of x
natural log
times
of
natural log
x
of x.
plus
Now I can
sine
differentiate
x
both
over
sides.
x.
So this would be
times
1
the
over
original
y
problem,
prime,
they'll all
which
be
was
like that.
2x to the sine x.
Over here, I'm going to remember to use product rule
Okay.
with these
So
two.
you're going to just
Okay.
have to recognize
go to
when you have
differentiate
to use
this
this
type
type
of
of differentiation.
differentiation.
You can
product
use it in
rule
other
with
cases,
root
but
x and
anytime I
natural
have
log
an
of
x in the
x.
base
So
and the
derivative
power,
of root x,
I
I
have
have
1
to use
half
logarithmic
x to the negative 1
differentiation.
half times natural log of x plus root x times 1 over x. Okay, make this look a little neater. I have 1 over y prime equals, if I change this, what would I have? Natural log of x over 2 root x plus root x over x. That's just simplifying each term, guys. X to the negative 1 half is over root x. And then again, I'd have to multiply both sides by y. So y prime would be my answer plus root x over x times the original problem, which was x root x, in order to get the y prime by itself. Okay? And last one, similar. Okay, so I have 2 times x to the sine x. So I'm going to, I can write this, it's just y equals, don't let that confuse you. Take natural log of both sides. Okay. Now I can actually split the right side up. So that's really the natural log of 2 plus the natural log of x sine x to the sine x. Okay. And then all I'm doing, I haven't differentiated yet. I'm just using my log rules. Bring down the sine x times natural log of x. Now I'm ready to differentiate. So this would be 1 over y prime. Derivative of this would be 0. It's a constant. Okay, so then I would have to use product rule with sine x natural log of x. So derivative of sines cosine times natural log of x plus sine times 1 over x. And then I would just multiply by y to get the y prime. So my final answer would be cosine of x times natural log of x plus sine x over x times the original problem, which was 2x to the sine x. Okay, so you're going to just have to recognize when you have to use this type of differentiation. You can use it in other cases, but anytime I have an x in the base and the power, I have to use logarithmic differentiation.